Students, you are welcome to sirMATHS. Let's embark on this thrilling mathematics journey together. Today we are going to discuss decimal fraction as it concerns grade 7, equivalent to JSS1. Decimal fraction is our topic. Under this decimal fraction, we are going to treat the multiplication, also treat addition, subtraction, and division. Remember when we treated fraction generally, we said that decimal fraction is a fraction expressed in decimal form. And so we are going to do the operational aspect of it. We start with multiplication. All right, let's start with addition. Addition, as it concerns decimal fraction, is the same addition we know, but as it concerns decimal fraction, the arrangement matters. The arrangement is very important. Where we put the decimal point at a vertical straight line. What do I mean by that? Let's solve one or two examples. Let's see, we are asked to add 0.32 plus 0.68. In arrangement, we have 0.32 plus 0.68. See, the decimal points are vertically straight. When it is not arranged in order, your answer will be wrong. It will give you a different thing. So we add ordinarily. 2 plus 8 will give us 10. We write 0 and carry 1. With the one we carry plus this 3 is 4. 4 plus 6 is 10. We write 0 and carry 1. 0 plus 0 is 0. Plus the one we carried. We have our 1. This is our answer for that. Let's have the second example where we are asked to add 2.346 plus 1.25. Here we have 2.346 plus 1.25. You can see in the first one we have 3 decimal places, and in the second one we have 2 decimal places. The first decimal place will be directly under the first decimal place of the first one, and the second one under the second one of the first one. You can see that this has no, the third decimal place of the first one has no partner. So this will be the arrangement, the decimal point in a vertical line. So we add. The 6 has no partner. We now see we bring down 6. Somebody can as well, to make it up, can put 0 here. You can put 0 here. It makes no difference in the value. So we now have 6. 4 plus 5 will give us 9. Y3 plus 2 will give us 5. And 2 plus 1 is 3. Our major interest here is the arrangement, because already you know this addition. Even from your lower grades, you know it. But I want you to pay attention to the position of the decimal points, to avoid making a terrible mistake. The third one, 0.632 plus 0.5. This is 0.632 plus 0.5. The second decimal place has no partner here. The same thing with the third. You can use 0 to make it up. Or you can leave it and just bring down 2, bring down 3, then add 6 to 5. So here we have 2, 3, 6 plus 5 is 11. We write 1 and carry 1. 1 plus 0 is 1, plus 0 is 1. So please take note of the arrangement. That is for addition. Let us now go to subtraction. Let's go to subtraction. Even this addition, when we have, let's have one word problem. So this very effect to addition, the word problem. Here we are told that Maya bought (9.8 kilogram), 9.85 kg of apples, and 0.66 kg of oranges. Now the question is, how much fruit did she buy in all? How much fruit did she buy in all? That's all together. This requires addition. So we have 9.85 plus 0.66. 5 plus 6 will give us 11. We write 1 and carry 1. The one we carry plus 8 is 9, and 9 plus 6 is 15. We write 5 and carry 1. 1 plus 9 is 10, and 10 plus 0 remains 10. It's a decimal point. Vertically straight. That is still for addition. Let's go to subtraction. Subtraction in decimal fraction. Let's have this first example. 5.91 minus 3.739. We arrange 5.91 minus 3.739. In the first one, the third decimal places has no partner, as we have in the second one. You can as well just use 0 to make it up. 1, 2, 3, 1, 2, 3. And then we subtract as required. We cannot subtract 9 from 0. We borrow this very one. On coming to this, it becomes 10. And 10 minus 9 will give us 1. Because we carry this very one, it's now 0. So we carry 1 from 9 to this, that will be 10. 10 minus 3 will give us 7. Why this 9? Because we carry 1 from it, remains 8. 8 minus 7 will give us 1. And this is 5 minus 3, 2. I still remind you the importance of arrangement. Second example to this subtraction. (0.872) minus 0.53. 0.872 minus 0.53. The third decimal place has no partner in the second value. We simply bring it down. This is 2. 7 minus 3 will give us 4. Y8 minus 5 will give us 3. And 0 minus 0 is 0. That's for subtraction. Let's have one question on this subtraction in sentences as word problem. Here we are told that Nathan had 5.2 grams. Nathan had 5.2 grams of pepper and then he used a part of it, which is 0.21 grams, and then we expected to find the remaining one. The same pepper. Okay, how much pepper does Nathan have left? This will require subtraction. Initially, Nathan had 5.2 grams and he used 0.21. So we add 0 here to make it up two decimal places. And we cannot subtract 1 from 0. We borrow 1 from these two. That one coming to the unit becomes to the second decimal place becomes 10. 10 minus 1 is 9. Remember, we have borrowed 1 from 2. What is left there is 1. And we cannot subtract 2 from 1. So we have to take 1 from 5. And when it becomes 10, that 10 plus 1 is 11. 11 minus 2 will give us 9. And this is now 4. 4 minus 0 will give us 4. That is subtraction in decimal fraction. Let's go now over to multiplication. I hope you are following. Multiplication. Multiplication under decimal fraction. Let's have an example of whole number and fraction. Whole number and fraction. And where we have 5 times 1.212. Whole number and fraction. We find a product. We can as well have it as 1.212 times 5. 5 times 2 will give us 10. We write 0 and carry 1. 5 times 1 is 5. Plus the 1 we carried is 6. 5 times 2 is 10. We write 0 and carry 1. 5 times 1 is 5. Plus the 1 we carried, 6. The same way, if we see fraction times whole number, the same process, fraction times whole number. But here, let us have fraction times fraction. Fraction times fraction. Let's have 0.35 times 0.4. I will advise you the best way to handle this is to ignore the decimal point at the beginning. Then after your answer, you now count the number of decimal places and reflect the decimal point in the correct place. What do I mean by that? Simply say 35 times 4. 4 times 5 will give us 20. You write 0 and carry 2. 4 times 3 will give you 12. 12 plus the 2 we carried will give you 14. Then you count the number of decimal places. We have 1, 2, 3. Decimal places, that is the figure, the value after decimal point. We have 1, 2, 3. Then you come back to your answer and start counting from your right. 1, 2, 3. So your answer actually becomes 0, 4, 1.0. This is your answer. This is equivalent to 0.14 because that 0 at the end actually has no value. I repeat, we ignore the decimal point and just pick 35 times 4. We multiplied ordinarily and it gave us 140. Then we count the number of decimal places we have in the question and we got 1, 2, 3. You start counting from your right of the your right hand side of the answer. 1, 2, 3. So we now put our decimal places and close it with 0. This is easier to avoid making a mistake. Let's have a second example here. 2.4 times 0.6. That is, we now say 24 times 6. 6 times 4 will give us 24. We write 4 and carry 2. And 6 times 2 will give us 12. 12 plus 2, 14. We count the number of our decimal places, and that is 1, 2. 1, 2. We count 1, 2. So answer becomes 1.44. 1, 2, 1, 2. Put our decimal point. That is for multiplication in decimal fraction. In the same way, even when it is a word problem, the same thing we did here is what we are supposed to do. Ignore the decimal point at the beginning, multiply ordinarily, and then recognize the decimal places and reflect it in your answer. I mean, the number of decimal places, like here we have 1, 2, and we start counting from the right of our answer, 1, 2, and put our decimal place between 1 and 4. That is for multiplication. Now let us treat division. Division. Let's have one example in division. We have 0.8 divided by 0.25. You can change this, decimal fraction into ordinary fraction. Do the necessary division and reflect back your answer in decimal fraction. What do I mean by that? We now have, in ordinary fraction, this is 8 over, this is 1 decimal place, 1 0, divided by, this is 25 over 1 2, 1 2. And you know, when you are dividing with a fraction, you now change the division into multiplication and invert the divisor. In other words, you multiply the fraction you are given by the reciprocal of the divisor. So that will give us 8 over 10 times 100 over 25. We solve on. This is 0, we cancel this 0. 5 here is 2, 5 here is 5. We collect what remains. We have 8 times 2 divided by 5. And that will give us 16 over 5. To make it easier to convert this back to decimal fraction, you simply say that you make this very 5 to be 10. And what do you do to make this 5 to be 10? You multiply this 5 by 2. And whatever you do to the denominator, you also do it to the numerator. That is 16 times 2 over 5 times 2. And that will give us 32 over 10. Dividing the 32 by 10, the invisible decimal point will move one place because of this one's rule, giving you 3.2. That is our division. I do hope you are following what we are doing. But if it is fraction and whole number, you can divide ordinarily. Fraction and whole number, you divide ordinarily. For example, if we are asked to divide 0.34 divided by 2, this is 0.34 over 2. 0 divided by 2 will give you 0. 3 divided by 2 will give you 1, remainder 1. That one remaining, and this 4 is 14. 14 divided by 2 is 7. That is our division in decimal fraction. Let's have another example to this effect. That is division. A whole number, or a fraction and whole number, 3.061, or rather 0.16 divided by 2. The same process we did here, we'll continue this here. 3.016 divided by 2. 3 divided by 2 will give us 1, remainder 1. That 1 and this 0 is 10. 10 divided by 2 will give us 5. This 1 divided by 2, it cannot. We write 0. Now 16. This 1 and this 16 divided by 2 will give us 8. That is for our division in decimal fraction. Let's have an example where we have combination. We have combination. A situation like 0.25 plus 0.5 divided by 0.2. 0.2. We can add this, but we have to observe bold mass. We have to observe bold mass, treating anything in bracket first, And in this very question, there's no bracket. If there's any exponent that is power, which is off, there's nothing like that. But we have division. So division before addition and subtraction. We handle division first. So we can as well say this is 0.25 plus. You can convert this into ordinary fraction for easy operation. This is 5 over 10. Why 10? Because this is one decimal place, 1 0, divided by 2 over 10. One decimal place, 1 0. That will give us 0.25 plus 5 over 10 times 10 over 2. You remember what we said when we are dividing a fraction by fraction? We change the division into multiplication and invert the divisor, the reciprocal of the divisor. So this is 0.25 plus, this is dividing this. We have 5 over 2, that is 0.25 plus 2.5. I hope you know that 5 over 2 is 2.5. You divide 5 by 2, it will give you 2, remainder 1. That 1, you add 0, divided by 2 will give you 5. So we can now add 0.25 plus 2.5. This will give us 5. 2 plus 5 is 7. 0 plus 2 is 2. What did we do? We honored both mass, where we treated division before our addition. This is division, where we have combination. It can be multiplication, division, addition, and subtraction, where we have the mixture of that. Let us have one question that will involve this combination. This is 1 plus 0.2 times 0.5. We have addition, we have multiplication. By the order of both mass, we have to treat multiplication first before the addition. That is 1 plus. Like I told you, ignore the decimal place, the decimal point, sorry, and then multiply ordinarily. Thereafter, you honor the decimal point. Here we have 2 times 5 will give us 10. But we have 1, 2 decimal places, and this is 1, 2. So put a point here. So we now have 1 plus 0.10. Ordinarily, this is 1 plus 0.1. So you can as well say point and use 0. This is 1, 1. This is our answer to that effect. This is a decimal fraction, where we treated multiplication, division, subtraction, and addition. And like I have told you, when you have a mixture, you honor both mass to give you the correct thing. When you jump any step of both mass, we mentioned that earlier, you will miss the correct answer. What you get will be wrong. However, I encourage you to subscribe to sirMATHS. Tune on notification to keep yourself updated in this our daily discussion on mathematics. Click to subscribe and notification button, and then that will keep you moving with us. I want to thank you for your listening and following me in this very journey for today. Thank you. We'll meet again next week by God's grace.